Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to continue on the making of some multi-sided indexes. If you recall, in the last couple of videos we made this 468 index. Off camera I had made a smaller one for up to 1 inch material, 468. And in the last two videos, we made one for up to 2 inch material. We made this out of round, square stock, primarily because our 4 sides, obviously, are square, and 4 of our 8 octagon sides match those same sides on the square material. Today, we're going to make a 3-5 index. I've made the prototype of it off camera with the smaller 2.5 inch material for up to 1 inch round stock. You see on this side we've got 3 sides, and on this we've got 5 sides. I'm not sure how much reflection I'm getting in the camera, the reason I keep turning it. You'll notice on the 3-sided one, didn't try to come out to a point. And I'll show you why when we actually lay this out on paper. Unlike the square where we laid out lines that we milled to, for this larger round stock, I'm going to lay it out on paper, take some rough dimensions, rough measurements, and then go straight to the mill on it. And also, instead of using the swivel base on the vise, we'll be using the rotary table on the mill this time. So let me get the camera zoomed in to the paper, and I will show you first how we'll lay out a triangle on a piece of paper. All right, I think I've got you where you can see what I'm doing now. Again, we're starting with a piece of 4 inch material. So I have my compass laid out with a 2 inch radius, and I'm going to draw this on one of the horizontal lines on my piece of paper. Alright, I'll come back to this setting on the compass in just a second, but we know, just like the larger piece, we want a 2 inch hole in the center. So I want to make sure our equilateral triangle we lay out in here does not interfere or is not too close to that center hole. So I'm going to come down to lay my compass out on a 1 inch radius, approximately, and draw that, what will eventually be that center hole. Now I want to make something absolutely clear in this video that I tried to make clear in the first 2 videos, but I'm afraid some folks didn't understand. Hopefully they watched the second part and saw what I meant. It makes no difference if this line is longer than that line, or that one is longer than that one. In other words, if I had milled in a little bit further here, this line would have been longer. The sides do not have to be exactly the same. That's why laying it out on paper is perfectly fine. What needs to be the same is the angles. In the hexagon, we were looking at 60-degree angles. Each side needed to be 60 degrees to its adjacent sides. The octagon, each side needed to be 45 degrees to each adjacent side. On the triangle, we're going to lay it out so that each side is at 120 degrees to its adjacent sides. So now that we've got this center laid out, and again, I'm saying all that just because I hope you realize that I understand that doing this with a protractor and on a piece of paper and taking some measurements is not the most precise way, but it is the simplest way and doesn't require any trig or really basically doesn't require any math at all. So now I'm set back to the original. Now the way you lay out an equilateral triangle is come on this same center line on the outside edge with your compass set the same as it was when you drew your circle. Put an arc and an arc. Now if we join those lines, if we join these two lines and we join from the point over here on this side, that's right through the center. Same thing up here on this arc. We have an equilateral triangle. However, see what happened? Because of the size hole we want in here, if we did this, we would be cutting into our hole. So what I want to do is leave approximately 1/4 of an inch between the edge of the circle and the edge of the triangle. Now if we take our calipers and measure that distance from the edge of the circle to the outside edge of our piece, in this case we'll come out with 0.984. Probably should be exactly 1 inch if we got a 4-inch piece and a 2-inch in the center. But since our triangle side intersected with the circle, I'm going to take that 0.984 and I'm going to subtract 250 thousandths from that. So that's 734 thousandths from the edge. You'll see where all this comes into play in just a moment. So that means that my edge of the triangle is going to be something like this. And if I did the same thing over here, I'm just guesstimating it for now, just to draw. But that would leave us 1/4 inch from the side of our triangle to the inside or the outside diameter of our center hole. And note over here, it doesn't come to a point. So let's lay this out. 0.734 is what we're going to mill off. That could be 0.750, 3/4 inch. It really doesn't matter as long as we leave enough meat in here. So I'm going to turn to the over to the mill now, get this piece set up in it, and we'll mill out the triangle. After we do that, we'll come back and flip it over and lay out a pentagon on the other side to do this. All right, over here on the mill, I've got the rotary table installed. I've got it set to 0 right now, and I've got the 3-jaw chuck mounted on the rotary table. So we're going to put our workpiece in, secure it down, and I'm just going to touch off on the top, set my Z-axis DRO to 0. Now we're going to come to the back side back here. Our first triangle side is going to be cut out of this back. We're going to go, this is a 1-inch piece, we're going to go 300 thousandths deep. That'll leave 400 thousandths in the middle. I tell you what, we're going to go 275 thousandths. All right, that depth is locked in. That depth will clear the vice jaws. Now what I want to do, I'm going to power up and I'm going to touch off. This is not critical enough to try to use an edge finder on. I'm just going to touch it off. Before I do that, I did find center on the x-axis and marked it on the DRO so that each time I touch off back here, I'm touching off in the same point arc of this circle. All right, that was just touching. So I just zeroed out the DRO on the y-axis. Now let's move over here. And I think we can probably take, let's start with 100 thousandths to begin with. Remember, we said we're going to take 734 thousandths. So I'm going to grab a pen right quick. And write that on the top just so I don't forget it. 734 thousandths. And of course, when I'm doing this, I've got the y-axis locked, and I also got the rotary table locked down. All right, I'm going to come in another 100 thousandths. All right, I'm going to continue this process. I'm not going to show as much detail in making these indexes as I did the 468, but I'll bring you back when we get ready to make that last cut on here. Okay, at this particular camera angle, it's probably hard for you to see, but I've got this edge, I milled up to the edge. I'm at 700 thousandths now. I'll move into 734. And again, that does not have to be exact. What needs to be as close as possible is where we turn this, when we rotate this rotary table in just a moment. So let's take this last 34 thousandths off. All right, I'm going back off on the y-axis. And I'm going to bring the x-axis back to the 0. All right, now we're going to unlock the rotary table and go 120 degrees. Watching not only this, but also the dial down here so that I'm dead on 0. Now I'm going to touch off back here again. Theoretically, that should be the same 0 on the DRO, but that would only be the case if the 3-jaw chuck was on the exact center, exactly centered on the rotary table, which I didn't try to do on this setup because it's really not critical at all. But let's just see how close it comes in. That's within 4 thousandths right there. So we will come back over here to the side. Our table, rotary table is locked down. Go in the start, the 100 thousandths, and mill this second side of the triangle. And again, I'm going to come in 734 thousandths. I'll bring you back when I get this side cut. Finished with the second side now, and I'm going to rotate on around. We will be stopping at 240 thousandths now. But I'm going to come right on around one time just so you can see what we've done. This was the first side, and here's the second side. And as you can see, we did not come out to a point. Remember, if we come out to a point, it was going to interfere with our inner circle, inner hole in here. So I'm going to go back on around to 240. Remember, we started at 0, then we went to 120 for this side. Now we're going to go to 240. And just to give it a glance over for a sanity check, and this intersection where these two angles come together should be pointing right straight back at me, which it is. So we'll come back to 0 on the x-axis. And again, we're going to touch off on this back side. Zero out the y-axis on our DRO. And we'll make our first 100,000th cut. And just like the previous sides, I'll mill this 734 thousandths deep. I'll bring you back when we get ready to start on the Pentagon. All right, we have our third side milled now. As you see, we got an equilateral triangle, pretty much centered on our 1 inch thick workpiece. I'm going to carry this over to the Scotch-Brite wheel, clean up some burrs on here, and meet you back at the desk or at the workbench, and we'll lay out the Pentagon on this side. All right, we're ready to lay out the Pentagon, our five sides on this piece. But before I do that, I want to come in here and go ahead and find the center on my workpiece itself. What I'm using is a center square. I'm laying out 4 different cross points, and then I'll select the closest to the center of that as I can see as my actual center. I'm going to set this over at the on the vise anvil block and punch that center. Alright, so that's going to be our center point. Now, over here on the paper, I'm going to lay out another circle. The radius is still set to 2 inches. And I'm going to lay out the center hole on this side as well, just to be sure we don't run into it with the octagon. I know we won't from what I did on the prototype, but just to show you. Alright, it's set on 1 inch now. Alright, so there's where our center hole will be. Now in the computer world, in my programming time, there was what was called constants. We could use all grades of math to determine where to lay out this octagon. But there's what's called a constant, in that the radius of a circle, in this case 2 inches, the relationship of the radius of a circle and the length of an individual side is 1.167. Let me double check my note I had on 1.167. So we multiply 2 times 1.167, 2 times 1.167 is 2.334. So we need to set our compass at 2.334. Now the way I like to do that is take my calipers and set them to the desired length, and just in my paper punch a couple holes in there, because it's much easier to set this compass on those holes than it would be to try to measure out 2.334 on the rule. And if I set it once, I've set it a dozen times in this first 2 videos and this one. These do not have to be precise at all. So what I'm going to do is set that, at any point on this circle. It really doesn't have to be on one that dissected the center. one of the lines on the paper. Now I'm going to arc. Let me back up. Now that was correct. I was thinking of a hexagon. So I will arc there, arc here. Now I'll move my compass to one of those arcs. Arc, arc. Now watch what happens when I join those those arcs I just made. Now we have a pentagon, and the only math was simple third grade math of multiplying one number times another number. In this case, it was our radius times the constant 1.167 to get the ratio or the relationship between the radius and the length of one side. So now we're ready to go back to the mill, put our piece in, and well, we got to take a measurement, Lee, to see how much we need to take off. So we're going to go from one of these. That looks like about 397 on that one. About 400 on that one. Same thing there. Just a little bit shy there. A little bit over 400. We're going to take 400 thousandths off of each side. Each of the 5 positions. And that still leaves us plenty of room for the center hole. So I'll simply mark, put myself a reminder, 400 thousandths. All right, I got you in a little different position this time. And what I'm going to do is mount the workpiece in the 3-jaw chuck again. And these points, or these intersects here that didn't come out to a point, actually work very nicely at this point to have something to clamp to. I chose not to go half the depth of the workpiece, just simply because that was a lot of unnecessary milling. The depth is still the same on our z-axis here. Now I said that was all the math we needed to do. There was a little bit more math that I needed, that we'll need here. Let me bring the rotary table back to 0. All right, 360 degrees. Not sure how well you can see this, but 360 degrees in a circle divided by 5 is 72. Remember up here, 360 degrees divided by 3 was 120. 360 divided by 5 is 72. So we're going to start with our rotary table at 0. Then we're going to go to 72 degrees, 144 degrees, 216 degrees, and then 288 degrees to get our 5 sides. All right, we'll go in our 100 thousandths and mill this across. Move in another 100 thousandths and do it again. I'll bring you back when we get ready to advance to the next location. All right, one side's done. Now we're ready to move 72 degrees. I went 77. I want 72. All right, I'm going to touch off. And that's within 2 thousandths, so it's perfectly fine. Move over here. Go in our 100 thousandths. All right, there's the second side finished. If anyone's wondering why I don't make a cut moving back in the other direction, this mill just simply isn't stout enough to make a 1/4 inch deep by 100 thousandths wide cut climb milling. It works fine as you're seeing conventional milling, but climb milling is just a little bit much on it. It obviously tries to grab the material. So now we're going to move to 144 degrees. I'm going to take these, I'm going to do these other 3 sides, probably do them off camera since this is all repetitious. But I want you to see in this too, since we did not have to make an adjustment from our layout, the points on the Pentagon will be, or it will come to a point on the Pentagon pretty much with the outside diameter of the workpiece. So I'll do the other 3 sides and bring you back when we get ready to put our center hole. All right, we've finished milling out our 5 sides to the Pentagon. I got the end mill out. I've got the drill chuck in now, and we're going to start a drill. I've located the center already and got the table locked down. All right, as I said in the previous video, 1 inch is the largest drill bit I've got. So I'm going to take the drill chuck out, put the boring head in. Got the boring head in now, and we're ready to start taking, again, some fairly aggressive cuts to get out to our 2 inch. And I'm going to continue this process. I'll bring you back when we get close to the end. All right, I think this cut and maybe one more, and we'll have our 2 inch clearance hole. Remember, we want a 2 inch piece to go in with no resistance. Okay, that's still about 100 thousandths shy. All right, that should be pretty close to 200 thousandths right there. Well, I mean, sorry, 2 inches. 1.995. All right, we want some clearance. I'm going to take just a little more. I'm going to make 2 or 3 passes through there at this setting just to be sure we take any spring out. All right, I've got the DRO set at zeroed. So I'm going to come out here just a little ways, and I've got a test piece that's 2 inches. And that goes in without any resistance if I hold it straight. So I think what I'm going to do now, I need to get the rotary table. Well, first off, I need to clean up all this mess, get the rotary table off, get the vise back on, get it trammed in. Then we'll put our hole in the side for our locking bolt, and also we'll cut a test piece, maybe a Pentagon on the end of one. And I know that piece is hot right now, but let's take it out and see what our clearance looks like on the other side. See, we've got that 1/4 inch right there that we were hoping for, or planning for. So I'll be back when we get set up with the vise back on and ready to do a demo piece. Okay, I got the hole drilled and tapped in our index piece now. This is drilled and tapped for 1/4 20, just like the other ones were. I've got it mounted on the same piece of stock that we cut the octagon on in the previous video. We're going to do a pentagon this time. And I've got it indexed with my square to one side of the pentagon. Of course, got a work stop here, so I keep the same distance. Now, in the upper right-hand corner of your screen over here, you'll see that you'll see the actual milling action. I'll be taking about 150 thousandths depth each time. All right, now I'm going to index it to the next side. Try to keep some chips out of the way up here. Loosen the mill vise a little bit. Two things you want to watch for. One, that you back to your work stop, well actually three. That you're lined up on a side of your index, you're at the work stop, and your workpiece is seated in the mill vise. All right, let's take a look at what we've got now. Okay, that was milling a pentagon on the end of a workpiece, 1.5 inch round stock, using the index that we just made. I hope you've enjoyed this series of making the indexes. In the next video, we're going to use one of those indexes for something other than just putting a shape on the end of a round workpiece. So stay tuned. We'll see you in the next video.